Can everyone hear me? Awesome. Okay, I'm just going to get started while a few people sort of trail in. So welcome to the session, not MacGyver's JavaScript. So what's this all about? So what we're going to be talking about today is some of the problems that people typically experience when they take some of the patterns that they've been using in smaller client-side JavaScript applications and they try and apply them to much larger and more complex JavaScript applications. And what are the kinds of things that start to happen and the problems that people encounter. But before we get started, I'll just quickly introduce myself. So I'm Amy. I'm a developer down in Wellington at a company called Green Button. And when you think of Green Button, we just do high-performance computing in the cloud. So we're bursting high-performance computing workloads up into the cloud, managing workloads, spinning up machines up and down, all of those kinds of things. So I write lots of C# code. But I also write lots of JavaScript because we're building a client-side web application. More importantly, who are you? So you are somebody who loves to write really great code, somebody who really likes to write clean, beautiful code. You wouldn't be here at TechEd if you weren't that kind of person. You're also somebody that knows the value of just putting together a really quick and simple solution when it's not warranted for any extra trimmings. And you're also somebody who knows the value of bringing in some of those extra trimmings when things start to get complex, because you know it's going to help you get the job done and get the job done well. And you're probably somebody who's played with a little bit with JavaScript. So this is not going to be a language fundamentals talk, but don't worry if you're not so comfortable with JavaScript, because what we're going to be talking about mostly here are concepts. So there's going to be some code, and I'm going to take you through the code, and the code will also be available on GitHub after the session. But don't worry so much if you don't follow everything that's going on. Just think about the kinds of concepts that we're talking about as we move through. So let's get started. Okay, so I thought jQuery would be a really good place to start. So what's jQuery? jQuery is a DOM abstraction library. And it basically gives you a way to interact with the browser's DOM, the document object model. And it takes away all of the pain of dealing with all of the cross-browser concerns, because every browser does things just a little bit differently. So I remember when jQuery burst onto the scenes, and lots of developers were really excited because it was like, I can finally write JavaScript code and get my job done without having to deal with these issues. It was actually pretty awesome. So the web filled up with modal dialogues and fade-ins and fade-outs, and they've got a pretty exciting place for a little while there. And a lot of developers really felt like jQuery was a toolbox of really awesome things that they could build rich web applications with. It was huge. So jQuery, a DOM abstraction library with the tagline, write less, do more. But as you keep building your app and you keep doing all of these great things with jQuery, your clients are loving it and they're telling you to build more and more cool things. And so you're adding in new features, and you've got about 500,000 jQuery selectors. You've got text boxes being edited. You've got things being filtered. You're showing and hiding things. You've got modal dialogues popping up. You're firing off an AJAX request. You're updating a text box. Oh, the AJAX request is returned. Let's do something else. Things get complicated really, really quickly. And so this kind of, when your application becomes really large, if the only tool that you have in your toolbox is jQuery, then it kind of is a little bit like a bomb. Your code base explodes. It basically becomes this brittle, unwieldy spaghetti code mess. So what we need to do here is stop thinking about jQuery like a toolbox and start thinking about it like a tool inside the toolbox. So the problem here is not jQuery. jQuery is a great library. The issue that we have is that we're trying to use it in a way that it's not designed to be used. It's a library that helps us do some really cool things to the document object model, and that's it. It doesn't do anything else. It doesn't help us structure our code in a way that's clean, readable, and maintainable. But it is still a really great library. So jQuery is a tool in the toolbox. So what do we do? How do we better structure our client-side JavaScript code as it starts to grow? Well, we can use design patterns to help us separate our concerns. And specifically, the design patterns that we want to be using here are presentation patterns. And what these presentation patterns are going to do is separate our data from our views. And so a lot of the JavaScript community kind of heard the developers' outcry, and they were like, we really need something to help us bring structure. And there was this huge explosion of new libraries and new frameworks onto the JavaScript scene. And they all had their own flavor of how to separate these concerns. They all kind of fell under this family of patterns, MV star or model view something. And all of these patterns are trying to achieve is a separation of concerns between your models and your views. So you've probably heard of some of these before. We've got MVC, Model View Controller. We've got Model View Presenter, MVP. We've got MVVM, Model View View Model. Do you know, it's actually not really that important what that other thing is. Well, I lie. It is actually quite important what that other thing is. But for the purposes of the point that I'm trying to make here, all they're trying to do, all of these presentation patterns have in common is a separation of concerns between models and views, between data concerns and view concerns. And it's this thing that's going to help you start structuring your code in a much more clean, clear, and readable way. So I mentioned that there's lots and lots of libraries and frameworks that are out there to help you do this. So how do you choose? How do you choose which one you're going to use, or whether you're going to use one at all to help you separate these concerns? Well, sometimes it feels a little bit like an unnecessary street fight. You know, everybody's kind of ganging it out about which one's the best and why it's the best. So what's the difference between a library and a framework? How do we choose this? Well, so a framework you kind of think of it like this all-encompassing being. Okay, so what's happened with a framework is the author of the framework has decided that there is a way that they think is most productive to structure their code. And they have built this framework around that. And you're going to basically write some code that fits within that structure, and the framework is going to call into your code. So if you contrast this to libraries, Hollywood principle, yep, exactly. Yep, don't call us, we'll call you. So contrasting that to something like a library. So the idea with a library is that they don't try and do everything for you. They generally just pick one thing, and then they try and do that really, really well. And all the stuff that goes around the call of the library, so you make the decision about how that looks and feels, and you're going to call into the library yourself. So if you went onto GitHub and you went, okay, well, what framework or library am I going to use to help me better structure my JavaScript code? You'd probably be there for a very long time because there are a huge number of frameworks and libraries to choose from. So I've got a very small list here of the most popular ones at the moment, and it's not even a complete list. And next to it, I've got the star count on GitHub, which is kind of an indication of relative popularity at the time. So if you were to go out and choose a library or framework, you might be likely to pick something like Backbone.js, simply based on how many blogs there are out there and how popular it is. So what is Backbone? So Backbone is an MV star library, and it's really, really small. So its minified production version is 6.3K, so it's teeny, teeny, tiny. It takes a dependency on another library called Underscore, which is also a relatively small library. But Backbone is so small that before you start using it, you can actually sit down and read all of the source code and actually understand what it's doing before you even start writing a line of it. And it's true to that library mentality. It's really unopinionated. So what does Backbone bring to the table? It brings to the table a couple of concepts: models, views, events, and a router. So the idea behind models is that models are the heart of your JavaScript application. Models are your data. Models are the functions that are associated with that information. Things like validation, security, any computed properties. All of that stuff logically belongs together. In Backbone, you're going to extend the Backbone model with your own domain-specific functions. And I'm going to show you this very shortly. With views, the general idea here is that you have a piece of abstraction that represents a small portion of the DOM. And it's going to be backed by a Backbone model. And when that model changes, the view is going to listen to those changes and perhaps redraw itself onto the screen without having to redraw large portions of the app. It's quite focused and well encapsulated. So if Backbone's key feature is that separation of concerns between models and views, the thing that glues those together is events. And so the idea here is you're going to use Backbone events to wire up events like, oh, the model's changed, and the view gets that notification and it says, okay, well, I need to redraw myself. So the last thing that Backbone provides is a router. So this is a way for you to provide linkable URLs deep within your application. And this is really important because we're moving to a model where we're no longer rendering our UI on the server. That render is actually done on the client. And so managing routes becomes a little bit problematic. So we want to provide a way for people to hop into our application and render a piece of UI that's perhaps a little bit down the chain and have our URLs reflect where we are. Be copyable, bookmarkable, all of those kinds of things. Okay. So I'm going to show you a quick demo. So this is party animals. Animals like to party. And so basically the idea is with this demo is we're going to invite animals to the party. So we're going to invite Bill to the party, we're going to invite Bob to the party, we're going to invite Ian to the party, and we're going to invite Mark to the party. But I didn't really like Ian because he was a bit rude to me, so I'm going to uninvite him. But then later on we made up and patched our differences, so I'm going to invite him back again. The party animals can RSVP by ticking the boxes. And then we're going to click Start the Party. And the animals are having a right hootin' of a time. Okay, so before I just jump into how this is all built and some of the concepts within Backbone, I'm just going to quickly show you the documentation for Backbone. So if you go to backbonejs.org, all of the documentation's there. So this is where you can sit down and start to get a little bit more familiar with some of these concepts. But I just want to show you the number of things that you get for free when using Backbone models and views. You get all of these functions. When you extend from a Backbone model, you're going to get things like syncing to the server. So you can do CRUD over HTTP. You can do validation, all of these kinds of hooks. You're going to get this for free. Okay, so the first thing we're going to have a look at in Party Animals is we're going to take a look at our guest model. So here, there's not a heck of a lot going on. We're going to take a Backbone model and we're going to extend it with our own functionality. And it's going to be our guest. So this is the guest in that guest list collection. It has a couple of defaults. When that object is created, it'll have an empty name and an RSVP that's false. And then we have a function that allows us to toggle the RSVP. So guests aren't particularly useful in their own right. We actually want a lot of people to come to our party, so we need a collection of guests. So Backbone has the Backbone collection. So here you can define a guest list, which is a Backbone collection. And what we're going to do is say that the model type of this collection is our guest. And so what this means is when we go and get the information about our collection, Backbone knows how to turn that into a party.guest object. You see that we've got a URL here. So that URL basically reflects the place that this information is being stored on our server. So I've got a server running at the moment, and you can see that if I was to go to whack guests, I'm going to get a JSON document back. And you can see that some people have RSVP'd and others have not. Okay, there's a couple of other functions on there about whether guests, how many guests have, which guests have confirmed and which guests have declined our kind invitation to the party. So views is the next thing. So we're going to take a look at the guest view, specifically the guest list. So the idea here is we're going to extend from Backbone view. And the first thing that we're going to do is say what our EL is. So the idea behind an EL is basically telling the view what portion of the screen this view is representing, or where it should go, rather. So if we were to go and have a look at the index page, so this is what gets served up the first time that we hit the server, is we basically get a very empty document. We can see that we've got a header, but really nothing else. We've got an app container. So this is the EL. What's going to happen is when we call render on this view is going to be inserted into the app container object. And how does that work? So the way that that works, if I go to the right file, is so the way that that works is via templates. So what we're going to do here in a nutshell is compile a template with a model. So here I'm using a jQuery selector to get a template, and I'm going to take that out of the DOM. So if we switch back to our index view, we can see that we actually have these script tags, which are text template types, and they have an ID, guest list template. And so this is going to be the view that gets placed into that app container element. And the way that that is done is you have to define a render method. Oh, I've done it again. Where am I? So the render function is something that you're going to have to define for every single view. And the gist of it is you're going to get a template, you're going to select a template out of the document object model, you're going to select that out, you're going to get the HTML, you might mash it up with a model, and then you're going to put that view inside its parent container. And you're going to do that every single time for a backbone view. Okay, so that's models, collections, and views. What about events? Okay, well, here we have an example of some events. We've got this events hash, and these events are particular to what's happening on the DOM. So these are click events, things like whether the invite button has been clicked, whether the checkbox has been checked. And when those events happen, these functions that are associated with it will be called back. So for example, delete will be called back, or toggle RSVP will be called back. So you can wire up DOM events, start listening to DOM events. And the other thing that you can start doing is listen to model events, so things that are happening from the model. So here you can see the view is actually listening to the model's destroy event. And once that happens, the view is going to remove itself from the screen. Okay, and the very last thing is, how does this all kind of fit together? So this is where the backbone router comes in. So here we're going to define a backbone router. We're going to extend from backbone router, and we're going to have a couple of routes. We've got the root route, and we've got the start the party route. And when either of those changes occur in the address bar, Backbone, via something called the History API, is able to get notified of that change and then run these callbacks. So for example, show the guest list on the root URL. So if we were to go back here and hit that root, what's going to happen is at that point, this code is going to run show guest list. It's going to create a new guest list collection. It's going to create a guest list view and say that your collection is the guest list, and then it's going to fetch the contents of that collection from the server. I've actually wired it up so that this list is actually listening on initialize, it's going to automatically render itself. So that's very quickly models, collections, views, and events, and the router in Backbone. So there was a lot going on. Don't worry if not every line of code completely made sense. All of this code is going to be available on GitHub after the talk. But to recap, what we have here is we have a model that's backed on to an API. And this model is able to fetch changes from the API and put changes back when things are perhaps deleted or updated, and so on. Then we have a view. And the view kind of sits between the DOM and our models. And it's going to mediate, it's going to listen to events on both of those things, and it's going to mediate changes in both directions. So that's where Backbone Events comes in. And lastly, we've got a router that's listening to URL changes in the address bar and then making a decision about what to render in the view at any given point in time. So we can also programmatically push changes to the address bar, and this is via this Backbone History API, which I haven't covered, but there is an API that you could use that the browser's exposed to basically programmatically push changes to the address bar to make it look like that you're going back to the server, but you're actually not. It's just appending some information to the address bar, which your router can then pick up and render a new view. So again, the end result is that our client-side application is made up of lots of small, really focused models and views, nothing spread out, and everything's really neatly encapsulated. until complexity increases. So everything's relative, right? Well, what we just saw is that Backbone helped us structure our client-side code a little better, but as things are going to scale, there are going to be some problems that we see with that. It's going to reach a ceiling where things become hard again. And the kinds of problems that we encounter are headaches with routing. So that router that you saw, that had 2 routes in it. Can you imagine what the routing file would look like for the Windows Azure management portal, for example? And that's a pretty big single-page application. I'm not sure whether it's actually written in Backbone, but it will have some concept of routing. And it's going to, I can't imagine how big that route file must be. So the more complex your application gets, the harder that routing gets to do, the harder routing becomes. The other problem with this code is that we seem to do the same render method over and over again. We're writing that code over and over again, and I mean, that just doesn't scream dry to anyone, really. So we're going to get the template, get the model, compile them together, and put them onto the view. This is surely something that we can not repeat over and over again. And events become really complex. And the reason for this is that they're quite granular. So you've got a whole bunch of models and views kind of floating out in space, all raising events, which can be listened to by any object they really want to. And it becomes like finding a needle in a haystack. Like sometimes you have so many events going around that it's very difficult to see what's going on and very difficult to debug what's happening. And this is because the events are way too fine-grained and way too open. And the last problem that people typically encounter are memory leaks or zombie views. And so what happens here is we create a view, and perhaps it's listening to changes on the model, and then we close that view, we remove it. But we didn't unbind any of those events that it was listening to from the model, so it's actually still in memory. And then we have a new view that comes along, backed by the same model. The model continues to change, and weird things start to happen because we've got this view floating around in memory, but not on the screen, responding to those events. And that's a bit of a nightmare. So the majority of the pain that we saw as our Backbone application got larger is basically in white. They occur somewhere around the router and somewhere around the view. Those are the pain points. So what you actually end up with is MacGyverism creep, right? Like, so people start coming up with really creative solutions to get the job done in the face of adversity, which is commendable, but it also opens us up to a world of hurt as our application continues to grow. How do I test these things? How do I write unit tests for these things that aren't well separated? The concerns aren't neatly separated. How do I know where to make a change when a new feature is requested, when everything's kind of intermingled together? So why wasn't this presentation pattern helping us achieve our utopia? Well, the answer is that MV stars, they are presentation patterns. So they are not, presentation patterns are not an architecture. They're pretty good at doing something, and that's presenting things, but they're not good at doing anything else. They don't give you any hints about how to structure beyond just presenting things onto the view. So how do we build really big JavaScript applications in Backbone specifically without wanting to stab our eyes out at the end? So I mentioned before that I'm a C# dev, so I've spent a bit of time building desktop applications in things like WinForms, WPF, and even Silverlight. And if there's one thing that this experience has taught me, and it's how to build modular, composable applications. Applications which will readily accept changes into the system over time, in a way that remains, that the intent doesn't get lost in translation and remains really clear. So if you've done any kind of Windows desktop dev, or any kind of actually any kind of, you might have heard of this term before, composite applications. So we can apply the patterns used in composite applications to larger client-side JavaScript code to help us scale, to help us readily accept changes into the system. So I really like this quote. So this is a guy who wrote another JavaScript MVC framework called JavaScript MVC. And so what he said was, if we want to build really large JavaScript applications, we should just stop. Like, don't. Just don't even try. Build small applications. Test those small applications in isolation, and then assemble them together at the end to make your larger application. And this is a really nice idea. So before we start moving towards this model, we need to start wrapping up all of that, those modules and all of those models and views into well-defined modules. And sometimes it can be a little hard if your code base is kind of all spread out and you've got views and models everywhere. It can be a little bit hard to kind of work out which groups of functionality belong together. So I've got a bit of an example, and that's the Google Plus web app. And so here we've got something that allows me to post to the Google Plus timeline. It's independent of everything else on the page. And this is really a module in its own right. Same goes for the feed portion of this UI. This could be a module in its own right. It doesn't need the thing that posts to the timeline in order to function. In fact, pretty much everything on this page could kind of be grouped together into a module. But this doesn't mean that modules need to be kind of widgetized. They might not have any UI component. This is just an easy way to sort of start thinking about what modules might be. So modules are a small piece of functionality, a small piece of distinct functionality that's going to work in its own right. And a sign that you're decoupled in your application is that when you remove one of those modules, your application doesn't break. So the only thing that is lost is the functionality that module brought to the table in the first place. And above all, the best thing about modules is it stops us from polluting the global scope. So global variables are bad in any programming language, right? And it's quite unfortunate that JavaScript makes it really easy for you to create global variables, and modules is going to help you not do that. So a change to one module doesn't impact the other. And you should be able to put a module on a new page in isolation from other modules, and it should still work in its own right. And remember the presentation patterns that we were talking about, all of that neat stuff with models and views? Well, that still plays a big part. It's just that that now lives inside a module. And it's not necessarily a one-to-one mapping either, so you're not going to have one view to one module. It's got to be big enough to be useful, but you don't want it to be too big because then it becomes unwieldy and hard to manage in an application in its own right. Okay, so now we've got everything kind of wrapped up in these nice modules, which I'm going to show you what that looks like in code a little later. So we've got these things wrapped up in modules, and they're all kind of floating around in space. How do they work together to do something useful? Well, they could self-organize. They could sort of communicate amongst each other and decide who's going to place their view when, and kind of it would happen organically. But the problem is this is going to create dependence. So if one of these modules has an issue, maybe it's removed or maybe it has a bug, then the impact to that larger community of modules is actually quite huge. So we really don't want to be doing this. So to think about what we want to be doing, I'm going to use the analogy of an airport. So what would happen if planes ruled the runway? What would happen if planes decided when they were going to take off, when they were going to touch down, whether they were going to refuel, whether they were even going to go at all? I'm pretty sure that the airport would be in chaos, and there'd probably be a fleet of ambulance officers and fire trucks at the end of the runway. It would be pretty awful. So thankfully, that's not the way that the airport works. We have an air traffic controller to help us bring order to the airport. So this centralized controller is key to its success. So all the planes are going to communicate via this controller. They're going to ask for permissions to touch down and take off. And in this way, chaos is averted. So we don't really have an air traffic controller dude yet to represent these functions, but we need to introduce one. We need to introduce something that represents the orchestration of all of our modules, and we need this to be a first-class concern within our application. So we've kind of got the beginnings of, this is a very simplified diagram, we've kind of got the beginnings of an application architecture, if you will, appearing. So we have an area of our application which is responsible for the orchestration of modules. So in terms of composite design, this area of our application is going to be in charge of a few different things. And one of those things is the startup of our app, managing the lifecycle as a whole of the application. So this is our point to bootstrap. Do we have any configuration values that we want to load in? Do we need to start up the Backbone History API? The second one is eventing. So the idea here is that this application object is going to house within it, this area is going to house within it one or many communication mediators. And so the idea here is that rather than modules communicating directly to each other, they're going to go via this mediating source, right? And this is really good because it gives this source an opportunity to kind of orchestrate behaviors between modules. It's going to decide things like, does this module have permission to talk to this other module? Should it be asking this question? Is it the right time? Is this safe? It's going to have all of those kinds of concerns. It's going to be able to take care of those. Life cycle. So this is managing the life cycle of all of our different modules. When is it safe for a module to start, and when is it safe for a module to stop? And the last one is the placement of our views. So if we've got all of these modules with views inside of them and they're all really just trying to express themselves, we can't have that. Like, it wouldn't make any sense at all. We need something to decide and orchestrate what views are going to be placed where and when they're going to be removed. So we're going to place our views inside a shell, which may have many different portions to it. Perhaps a nav bar or a content area or a footer, for example. So each of these functions that I've just talked about, they're housed inside this area of the application, but they each deserve their own level of encapsulation. So we've successfully rounded up all of our models and our views, and we've stuck them into these well-defined and well-contained modules. And we have all of these modules communicating via this mediated source, which is giving us a place to orchestrate behaviors. And we have this unifying application object, which is able to compose behaviors and the presentation of each of our modules. So composite applications like this that are built in this way are able to readily accept changes into the system. And that's because you can swap out a module and it's buffered. You're able to make changes and it's well contained. You're also able to very quickly at a glance determine where is most appropriate for you to make changes, because things are kind of grouped into very logical areas. So can we build backbone applications this way? Well, of course we can. We're all programmers. So we could write our own code to do this. These are structures that are actually quite well defined. These are patterns that are quite well defined. But we could also look to libraries to help us get the job done. And if we're building backbone applications, I would strongly recommend that you check out a library called Marionette.js. So Marionette is a set of extensions to Backbone that helps us build this composite event-driven architecture. It's written by a guy called Derek Bailey. He's super smart. You should look him up and read his blogs. It's about 14K. So to put that into perspective, it's about half the size of jQuery and about double the size of Backbone. So with all of the neat things that it brings to the table, I feel like you can justify bringing it along for the ride. So Marionette can be split into two parts. And the first of that is a set of extensions for our model view whatever, to reduce the boilerplate code that we saw there. And the second thing that it brings to the table is a set of extensions to help us build this composite event-driven architecture. So one of the downfalls of Backbone views is that we had to do all of that plumbing code. We had to wire up all of the events, and we had to think about unbinding the events, and we had to write the same render method over and over again. So Marionette actually started out as a library that tried to stop that. It tried to put all of that stuff into a single place and just not repeat yourself. And then it grew into this thing that supported a composite design. So I think we'll have a look at two of the things that Marionette provide you. Marionette provide a few different kinds of views which extend from Backbone view. We're going to take a look at the item view, and we're going to take a look at the collection view. So on GitHub, I've actually implemented the same app twice, once in Backbone and once in Marionette. So you can take a look. They both do the same things. They're just using the different principles. So if we jump into the party animals module, we can see here that we've got things like an animal model and a party model, which is a collection of party animals. And then we can see that we've got an animal view. And so here, before in the Backbone implementation, this would have been a Backbone view, but now it's a Marionette item view. All we've done here is define a template. We only need to give it a template. So this is which template in the index file or that's loaded into the DOM are we going to use when we render this view out. That's all we need to do. That render code is already written for you. It's given you you got the regular hash from Backbone events. So this is something that Backbone provides. But the other interesting thing that it has is model events. And so you can very quickly, rather than using that listen to syntax, you can very quickly start listening to events and changes on the model object and have functions called back when they occur. And the advantage of doing it this way, and the advantage of using Marionette item views, in fact all Marionette views, is that if you're wiring up events via the listen to syntax, which is what this is doing under the hood, they will automatically be unbound when the view is closed, which is super awesome because you're not going to get any of those zombie views coming into play. So an animal's pretty cool, but we want him to be a party animal, so we need to put him into a collection. So we've got a collection view. And notice how small this becomes, right? All we're doing is saying, hey, Marionette collection view, here's an item view, here's an animal view. So when you're rendering out the collection, this is the view that I want you to use for every item in the collection. And we can also give it an empty view. So if no one came to your party, you can say that you smell or something like that. I don't know what you'd say. So that's the Marionette item view and the collection view. So the gain of using Marionette here was that we've significantly reduced the amount of boilerplate code that we were writing over and over again that we'd normally have to do when we were using just plain old backbone views. So the second thing that Marionette gives you is a set of extensions to help you build, a set of components that can help you build this composite event-driven architecture. So it gives you a mediated eventing system, an application object which encapsulates the composition of modules. So let's take a look at events. So Backbone Wrecker, so Backbone Wrecker is a new library that actually used to be part of the Marionette core, but it's so useful that it's been pulled out into its own project. So if you're ever wanting to do eventing in any JavaScript code, I'd recommend you take a look at Backbone Wrecker. It's a really interesting project. So Backbone Wrecker has a couple of things. It has an event aggregator, it has an implementation of a request and response pattern, and an implementation of a command pattern. So I'm just going to show you the event aggregator today. So the idea here is you're going to create a new Wrecker event aggregator. And then somewhere in your application you're going to say, on foo, so on the event foo, I'd like you to run this callback, this function. And then somewhere else in your application you're going to trigger that. So perhaps in another module, you'll trigger the event foo, and console.log foo event will be run. So what about the application object? So Marionette has this application object that I've been talking about, and it's really simple to instantiate. A new Marionette application, and you start your app. And when the app starts, there's a bunch of lifecycle events that you can hook into. So things like when the app is initializing, just before it starts initializing, and then just after. So it's your opportunity to start doing things like starting the history API, or loading in configuration, or whatever it is that you need to do. We can also manage module lifetime. So in Marionette, modules hang off of the application object, which is cool because it means we can say, start the application, some random module, I'd like you to start. And then sometime later, when it's appropriate to stop that module, we can say, stop the module. Fairly self-explanatory. So that Backbone Wrecker event aggregator that we talked about just before, so by default, every Marionette application object gets one of these for free. So you can add as many event aggregators as you want, and I really do recommend that you think about the way that you structure those eventing systems. You don't want to have everything going out on the global vent, and because you're going to end up in a much similar scenario to having all of your models and views publishing events and being subscribed to by anybody. So I would really recommend using the global vent for things like perhaps maybe an error occurred in one of your modules. So some of these like cross-cutting concerns. So a module might have an error, it's going to trigger foo or maybe error, and the application vent is going to have its callback called, and it can deal with whatever error that was. So the application object also has this concept of regions. Okay, so this is a way for you to define the distinct areas of your application in terms of a UI. So we might have a content region, a sidebar, a navigation, a footer. We basically just give it selectors, and then Marionette's able to work out what portion of the UI we're going to put views into. And that looks a little bit like this. We're going to, once our application started, we can say, hey, in the content region, could you please show this new view? And Marionette knows how to call the render method and stick it into the right place. So the last thing that Marionette gives you is modules. So defining a module, so on the application object there is a function called module, and it takes a string, which is the name of your module, and then it takes another function, which is going to be your module itself. So I think we're going to dive back into party animals. So party animals here, this is the Marionette implementation, and we've just done that. So party app is our application object. And I've created a new party animals module, and I have then passed in a function. So all of this here is the module itself. So the things that are going on inside this module, we have an animal model, we have a party collection, we have an animal view and a collection view, we've got the empty view, and we have a controller. And so this is a Marionette concept. So it basically just, I think it's just mixed in with events, so it gives you the eventing system. But the idea here is that we're going to use the controller to orchestrate the things that are going on inside of our module, so that that doesn't become a wider application concern, it's simply a module concern. So we've managed to say goodbye to all of that crappy boilerplate code, and we've kind of reduced it down to something that's very simple and clear by using Marionette. All of the events are wired up automatically, and they're also unbound at the end, which is really, really helpful. And those render methods have been written for you. So our application object can now be, our application can now be composed and orchestrated at the root, rather than made up of all of our views deciding when and where they're going to place themselves. And so this dramatically is going to improve the readability and understandability of your code base. So I feel like I've only scratched the surface of this library. So there's one of the great things about this library is that it actually is a library. So if you didn't want to build a composite event-driven architecture, you could pull in Marionette and simply use the views to get rid of all of that boilerplate code, and that would be a huge one. The other thing that I really like about this library is it actually is quite a treasure trove. So if you go and read the source, there are some really interesting implementations of patterns, some interesting conversations going on in the issues, and there's a lot to be learned about how to structure large JavaScript applications by just paying attention to what's going on inside this library. It's extremely well documented, and it's taking contributions, so I would encourage you to go and check it out. So if that was all too long and you didn't read it, complex JavaScript. If you've got complex JavaScript, jQuery is simply not going to be enough for you anymore. You're going to have to widen your toolbox. Start small and start separating your concerns. Start separating your data concerns from your view concerns. So Backbone is a really awesome way of being able to do this. But scaling it to really big applications is actually quite difficult. So presentation patterns, they're not an architecture. Our large JavaScript applications need a little bit more than just a presentation pattern to get them going. And they need to be composed of smaller parts. And application orchestration then needs to become a first-class concern. So make your applications dance and put them on a Marionette. Related content. Check out Backbone, the Backbone docs, the Marionette docs, _ and I'll put the samples are up on GitHub now, so you can check those out. Are there any questions? Mr. Glenn. Angular. I wondered if you were going to ask this.
Yes, I was. Well, I watched your last talk, and I since got into Angular after your meeting. I was very impressed with some very easy, but I'm interested to know what you think about what Angular, as you can see on the stars, is getting very, very popular.
It is. So Glenn's question was, what is Angular bringing to the table? So Angular is a framework of relatively the same popularity to Backbone. And from what I haven't actually used Angular in any anger, so I can't really form an opinion about how well it scales. But from the small bits that I've read and the documentation that I've read and the people that I know that are using it, generally the feedback is it's pretty damn good. The thing that I hear over and over again is that sometimes people have problems using this thing called Angular directives. And this is a kind of a construct that is specific to Angular. And people have a hard time with that because what I think they tend to try and do is use Angular directives to and kind of mix it in with jQuery plugins. And people tend to fall over. And I hear this story over and over again. And I don't know whether that's because directives are not designed to be used that way or whether Angular should support it. I'm not sure. But in general, the feedback that I hear from Angular JS is that it is awesome. So it's another thing that you can check out. Yeah. Ember. Okay, so the question was, how do I feel about Ember, which is another framework? And I don't know, because every time I go to their website, it's confusing and the documentation's out of date, and I don't know. Like, I'm not sure. It's generally it's a confusing space. Like, I think the guys that are working on that are really trying to sort it out. But, I mean, at the moment, it's difficult to make heads or tails because it's changing at such an alarming rate and things are out of date and it's massive, it's huge.
I guess kind of related to that, the good idea from a lot of people is they don't want to pick a framework, but they're scared to pick a framework because it's supporting Java,
Yeah. So the comment there was around people being afraid to pick frameworks or libraries because they're worried that if support stops for those and development stops for some of those open source projects, that they're going to be left with a really old and cruddy framework that no one wants to work with. And like, those are valid concerns, and if those are concerns that you are worried about, you've got a couple of options, and that's maybe contribute to the project. Like, most of these projects are open source, so you can actually start being some of the people that keep these projects alive by contributing back changes. And that's really, really important. Like, open source is something that we need to all kind of take responsibility for, especially if we are using open source projects. And the other option you have is just don't use one. Like, these patterns, these things that we're talking about, like, you can build this yourself. Like I said, Backbone is tiny. It's really small. And the things that it has inside of it, they're not really rocket science. You could sit down and emulate some of these concepts. The key thing that you're trying to do, the repeated thing that you're trying to do, is separate concerns. It's always about separating concerns. So if you keep that in mind, I think you'll be good.
The other thing I've heard from the notebook is that it's hard to retrofit Ember into a code base that wasn't built with Ember.
In mind. Yeah, and so the comment there was. So the comment there was that Ember is actually really hard to retrofit if you've got existing JavaScript, and that's one of the advantages of using something like Backbone. Because it is a library, you can just decide, hey, I really need models, or I really need views because I want to separate those concerns out. And it's a really easy way to start small and start refactoring your jQuery code into code that's more separated and more clearly defined. Am I testing JavaScript? Yeah, yes, I am, and I'm learning a lot about testing JavaScript because my first attempts were pretty terrible, I'll admit. But if you're not using unit tests, you're not writing JavaScript unit tests, it's definitely something that I would encourage you to do. What it does is it kind of teaches you about some of the problems and common downfalls that you experience when you're just mashing out code, you know? Like, it's just the same as regular testing. Your designs improve, testability improves. Please do it. It's a good thing. So, any advice to a company that's trying to choose? That's tough. Like, I think it depends on the kinds of developers that you have working. So if you've got developers that like freedom and like choice and really want to kind of define the way that something looks, then I'd probably encourage you to look on more of the library side of things. But if you're kind of not really worried about that and you're very comfortable with some of the ways that some of these frameworks are kind of approaching things, then that's going to be a huge win for your company, because productivity is, like, there might be a little bit of a learning curve, but generally I find with Backbone the learning curve is generally a little bit steeper than it is for something like Angular, for example. Okay. I definitely think people should be using something like Require. I haven't actually used Require with Marionette. I haven't had a need for it, although very soon I know that I'm going to need to do it. So there is some guidance around how to do that. The difficulty there is because it's hanging off the application object. There's a few extra steps that you have to do to get that to work. But definitely Require.js is something that you should look into. Or just any asynchronous module loading is a good thing. No, I haven't. I wish I had. I'll have to answer that question with a no. I'm sorry. I'll have a look later and maybe we can chat after the session. I'm interested to hear your thoughts. Okay, I'm not sure how we're going for time. Oh, we've got a few more minutes. More questions? Anyone got more questions? Or if... Oh. Hi.
This obviously applies to single page applications differently. If you've got an application that's a bit more old school, razor tiles.
Yep.
Which bits apply, which bits shouldn't apply?
Well, the first Marionette app that I wrote was actually just, it wasn't a single page application, it was a page. But there was enough going on that I really needed a little bit more than just some random views. There were lots of, it was actually reasonably complex. There were lots of events being raised, and I mean, having that separation of concerns was really good. So the answer to that is that it really depends on how big and how complicated that is. But it definitely applies. You can totally use Backbone or Marionette in a page that's not a single page application, just has a lot of JavaScript. Yeah, so the question was around how do you debug memory leaks in Backbone. So, well, WebKit has a reasonably good debugging environment, so that's the first point of call. But if you really want to visually see what's in memory at any given point in time, there is a plugin for Chrome for the WebKit inspector. I forget what it's called. I'll look it up afterwards. But there is a plugin that you can install, and it basically gives you inside the inspector window, it gives you a view over all of the models that are being instantiated and running in memory, and it gives you a view over all of the views. So you can basically keep track of what objects are running where. And sometimes it's a good thing to look at, because you build all this code and then you open that window up and you're like, crap, I've got like 400 views. Like, when did that happen? Because you put things in a collection, there's a layout, there are kind of pseudo views being created. Like, it's really easy for it to get away from you. So I'll find out what the name of that plugin is, and I'll let you know. Okay, are we good? Oh, well, thank you everyone. That was awesome. Thanks so much.